Hang on 1 second. Make sure I got everybody here. All righty. All righty. So test one review. All right. So the first three were graphing type questions here. Let's see. So number one wanted me to graph by plotting points. And they're giving us 6y plus 3x equals a -3. So I'll do these by hand. If you do this on the calculator, you got to solve that for y for sure on that calculator. So I'm actually going to do that by hand also. I'm going to solve this for the y. So remember, when you got an x and y equation like this, linear, you just want the x's on the other side and that to be a 1y when we're done. So we'll start out by subtracting 3x from both sides. So the 6y will come down. 3x, -3x cancel on the left side. So on the right side, these are not like terms. So I'm just going to put my x's first and then my numbers. So that's going to give me a -3x minus 3. So just keep the signs the same on this. And then the last step, make that a 1y by dividing everybody by 6. Hey, also the 6 divided by 6 gives me a 1y like I wanted right here. Cannot divide that -3 by 6, but we can reduce that fraction down. So that -3/6 will reduce to a -1/2 x. And I basically just divided top and bottom by 3 to get to 1/2. And then this will be minus 3/6 again, which will give me a 1/2. All right, at this point, you could put this in the calculator and get 2 points to graph it on MathLab and all that fun stuff, okay? I'm going to do this by hand, though. So by hand, I need 2 points. And, I'm just going to use 0 and 1 on this. I'll plug a 0 in here first, see what my y value is. Then I'll put that 1 in for the x and see what my y value is. So if I start with 0, I got -1/2 times 0 minus 1/2. Well, that's going to give me -1/2 times 0 is a 0 minus 1/2, which is going to give us a -1/2. Then I'm going to use that 1. So I'll put my 1 in. So -1/2 times 1 minus 1/2. All right, so -1/2 times 1 is a -1/2. So I got a common denominator, so I'm happy with this. So the bottom will stay 2 at this point. And on top, I got -1 minus 1, which will give me a -2. And that -2 divided by 2, I can reduce that to a -1. So those 2 points I'll graph for us. Now, the thing about MathLab, on this problem, it'll put a dash in between each number to represent the halves. So be careful in MathLab. It's going to go by halves on this instead of going by ones, okay? Righty, in Math Lab. You're going to use the line tool. Okay. So 0, -1/2, starting at 0 on the x's, I'm going to go down 1/2. So that's going to be the first tick mark they give you. And then my second point was 1, -1. So remember to go to 1/2, 1, and then -1/2, -1. And remember, you can watch in that little yellow band they give you as your points are moving. The Math Lab will probably give you a -0.5 for this point because it's probably going to keep it in decimals when you're moving it around on it, okay? But y'all, that's all I needed was those 2 points. And then at that point, draw your line. Okay, so not too bad. Just keep up with your points on that, okay? All right, y'all, number 2 was the same thing, but this time we're going to graph a different equation. This one, they want us to graph y equals x squared plus 4. You see that x squared right there? That's going to alert you that that graph will end up being a parabola, either facing upwards or opening downwards. But this one needs 3 points on it to graph. So I'm going to start my x and y table out. On the x squared graphs, I always use -1, 0, and 1 as my 3 points. Okay, so now just plug each of these x values in to get our y value. So I'll start with -1 squared plus 4. Now remember, whatever I get at -1, I'll get that same answer when I plug in that +1. Same thing for -2 and 2 on these graphs. So y'all, -1 times -1 gives you a +1 plus 4, and 1 plus 4 will give me a 5. So now I'm going to use 0 in for that x. So that'll give me 0 squared plus 4. Well, 0 squared is 0 plus 4, which gives us a 4. So when x is 0, y is 4. And then I'm going to plug in my 1. So what's neat is 1 squared is the same as -1 squared over here. So 1 times 1 is 1 plus 4. And 1 plus 4 gives us 5. And y'all, that's what you got to make sure on this one. Any x squared graph, you're going to have what we call symmetry on it. All righty, so let me go graph this one. So I guess I'll go out about 5. All right, now remember, like I said, in Math Lab, you're going to use a 3-point quadratic tool, the U-shaped tool with the 3 dots on it. So -1, 5 will be left to -1 and up 5. 0, 4, stay at 0 on the x-axis, go up 4 on the y. And then my last point would be 1, 5. So that'll be right 1 and up 5. I got you, Williams. All right, when you put that third point, MathLab will draw that parabola for you. So y'all, everybody's number 2 will be a parabola. Everybody's number 1 will be a straight line like we did. And then everybody's number 3 will be the graph I'm about to do. So this graph, y equals absolute value of x minus 3. So this is your absolute value graph, and it had 2 points. So it's a 2-point absolute value tool, but you gotta find out what the vertex point is. That will be the first point I plot. It's got to be that vertex. If you don't plot that vertex point first, it'll make the graph wrong, okay? So the first point to plot must be that little vertex, we call it. Now, here's the thing about it. To get this vertex point, the first x value I find has to make that equal 0 inside them bars. So only one number I can subtract 3 from and make that a 0. So that means my first x has to be 3, okay? So put a 3 in here. 3 minus 3 is 0. Absolute value of 0 is 0. So remember, the first point we plot must have a y value of 0. Okay, if your first point that you plot in MathLab don't have a 0 for the y, it's going to be the wrong graph, y'all. All right, so now I got 3 here. I'm just going to pick a number next to 3. And how about a 4? I'll use a 4 here. Inside the bars, 4 minus 3 is 1. Absolute value 1 is 1. And I'll tell y'all something else on this graph, y'all. Since there's nothing on the outside of these absolute value bars, every single y value you get better be positive on this one, okay? All righty, so I guess I can go out about 5 on this one. Now I'll do this one on the calculator also. So that y'all can see where that absolute value is again. All right, so I'm choosing the V-shaped absolute value tool. I'm going to plot 3, 0 first. So go right 3 and stay on the line since the y value is 0. So your first point has to be on the line, okay? And then 4, 1 will be right 4, up 1. And y'all, in MathLab, once I plot that second point, it's going to come in and draw your absolute value graph. Okay, so like I said, I'm going to show you that one on the calculator real quick so that y'all remember how to find absolute value. All right, y'all, so I'm going to switch over to the calculator. So go to y equals. So I need to get the absolute value first. So the easiest way is to hit math. Once you got math highlighted, arrow right until the NUN is highlighted for numbers. In the first choice, ABS, that's absolute value. So you would hit enter on that and bring the absolute value up. I'm going to clear that out. And there's a second way to get absolute value. The second way is using the catalog. which will be the second button, and the 0. The catalog's in alphabetical order, and y'all absolute value is the very first thing on it. So you could hit enter on that. Now put in your x minus 3. All right, so I'm going to look at the graph, and then I'll show you how to get to points. So hit graph. There's our V-shaped graph. And I'm going to show you on the points here. Second graph, I'll pull up the table. The first point you plot has to be this 3 because of that y value being 0. So whether you do this by hand or by calculator, that has to be the first point you plot, okay?
Okay.
I hear you. I thought I heard something. Question?
No, I was just responding to you. I said, okay.
Oh, okay. All right, y'all. So that's the main thing on the graphing is the first part's pretty heavy with graphing those first 3. Now, toward the end, we'll graph a little bit more, but it's going to be the stuff where we were shading. So now number 4 wants to determine whether the correspondence is a function. So this is where I had a domain on one side, and then I had a range on the other side. So for my domain, they're giving me a -2, 3, and 6. The range is a 4. And all of these are pointing to the 4. So remember, if this is a function, it's going to be a function because every element of this domain, which is my x's, corresponds to exactly one member of the range. Remember, the x's cannot have a choice. Well, this -2 only goes to one y value. This 3 only goes to one y value. The 6 only goes to one y value. So y'all, this is, yes, definitely a function. And then you got to put y because they'll have an A, B, C, D choice. So make sure you pick the one that says because each element of the domain corresponds to exactly one element in the range. Okay, so remember, it depends on the domain having one element in the range. Now, they'll put one of these that says because the range has one element in the domain, they'll have one sort of backwards. So remember, focus on the domain on these, okay? All right, then we started finding function values. So 5 says find the indicated outputs for f of x equals 4x squared minus 4x. Now, the first one they wanted me to start with was find f of 0. I want to change pens, change my color to blue here. So f of 0 wants me to take this little expression, put a 0 in for both of these x's. So that'll be 4 times 0 squared minus 4 times 0. All right, well, I like 0 because 0 squared is 0. And 0 times 4 gives me a 0. Minus 4 times 0 here is 0. And 0 minus 0 is a 0. So if that x is in every single term and you putting in a 0, it'll always give you a 0 for the answer. So y'all, once I put in this answer, it'll pop up and say, hey, find f of -1. So that means put a -1 in for both of these x's. So 4 times -1 squared minus 4 times -1. All right, so now I'm going to do my exponent first. So I'm going to bring down that 4. I'm going to hit the -1 and square it. So that's -1 times -1, which is a +1. And I'm just bringing everything else down. And then I'll do all my multiplying now. So 4 times 1 will give me 4. Now here, this is like a -4 times a -1. That's going to make that a +4. And y'all, finally, that 4 plus 4 gives us an 8. So once I punch in 8 for that answer, it'll pop up the third one, which is a f of 2. So they always give you 3 to do on this problem. So f of 2, I'm going to put a 2 in for both the x's. So 4 times 2 squared minus 4 times 2. And I'm going to do the same way. I'm going to start with the exponent. So I'm going to bring that first 4 down. 2 squared is 2 times 2, which is 4. All right, so I'm bringing everybody down now. 4 times 4 give me 16. Minus 4 times 2, which is 8. And let's see, 16 minus 8 gives me a final answer of an 8. So remember, on number 5, they will give you 3 to find. And this is one of those. I'm going to circle this number 5 because this is one of those where you got to send to work on plugging numbers in, okay? All right, y'all, number 6, we're going to determine if the graph is a function. So when I give you a graph to determine if it's a function, you're going to use the vertical line test. Okay, we're going to use the vertical line test on this. So y'all, the graph they're giving me is sort of sideways. So vertical line test says, for this to be a function, a vertical line cannot intersect this graph more than once anywhere. If it intersects it more than once, it's not a function. So you take your vertical line down that, and y'all look at that. It intersects it here, and it intersects it here. And it does it pretty much for most of that graph. So what's happening is these x's have a choice which violates our function. So if the vertical line intersects it more than once, you're going to put, no, that is not a function. Okay? So y'all, questions on this page? Y'all, let me see my chat popping up. All right, so y'all are good on that, and it looks like. All right, y'all, number 7 is a domain problem. So circle number 7, this is the second one I'm sending work in on, okay? So this one says find the domain of the function. All righty, my function is g of x equals 5 over 6 minus 5x. So the domain, the only thing we were worried about was fractions. Well, guess what? You're going to get a fraction on this one, okay? So to find the domain, I took the bottom of the fraction and I set it equal to 0. So I came in and I said 6 minus 5x equal to 0. And remember, I'm only worried about the bottom of the fraction. That's the only part that really can't be a 0 for it to be a real number, okay? So on this one, you're going to move the 6 over by subtracting it from both sides. So that cancels. I'm left with my negative 5x equal to a negative 6. And then divide both sides by negative 5. So this side, negative 5 divided by negative 5 makes that a 1x. All right, so here a negative divided by negative will make this a positive. And nothing I can do to that. So that's just going to be a positive 6/5. So that means 6/5 is the only number I cannot put in for that x to get a real number output. It'll make it undefined. So the answer you want to choose will be x such that x is a real number and then they'll give you a little box right here. In that little box, you want to put x not equal to 6/5. Make sure you choose the one with the not equals, okay? One of these will have like a less than equals type stuff, but you need the one with the not equals on it, okay? So yeah, this one might have an A, B, C, D answer on it, I think. All right, y'all, then we started getting into the what we call the algebra of functions. So for number 8, they want me to let f of x equal negative 10x plus 11. G of x is going to equal x squared plus 13. They want me to find f of 8 divided by g of 8. So f of 8 divided by g of 8. All righty, so I'm going to set this up like a fraction. They want me to put an 8 into the f equation and an 8 into the g equation. So on top is my f. So that'll be negative 10 times our 8, putting that in for the x, plus 11. On bottom, for g of 8, that's going to be 8 squared plus 13. All right, then it's just a matter of work the top, work the bottom, and then try to divide that if possible. So on top, I would multiply first and get negative 80 plus 11 over 8 squared is 8 times 8, so that'll give me 64 plus 13. All right, y'all, so finishing out the top, a negative 80 plus 11 is what, a negative 69. 64 plus 13 gives me 77. And at that point, I would try to reduce this if I could. But I don't see any factors, I think, that are in common on that top and bottom. So at this point, would be my final answer. Okay, so they're giving you the numbers to plug in. So just plug in your numbers and do your order of operations to it. All right, number 9 is another, we're going to find a difference this time. So they want me to let f of x equal negative 4x plus 4. G of x is going to equal x squared minus 2. We're going to find the difference g minus f of x. Now notice they didn't give me a number to plug in this time. Okay, so no number to plug in. So g minus f of x will equal my g equation minus my f equation. Y'all, subtraction, you always want to start out with parentheses. Now notice, this is g minus f. So g is x squared minus 2. F is the negative 4x plus 4. So the first thing you want to get the order right on this, g minus f. Now remember, since I'm subtracting, when I drop these parentheses, I'm going to distribute that negative through the second parentheses. All right, so let's drop the parentheses. This will bring a x squared minus 2 out. So the first parentheses always came out what we started with. But right here, you got a negative times a negative. That's going to make that a positive 4x. Then that negative times that positive 4, that's unlike signs. So that's going to make that a negative 4. So y'all notice, I only got one set of like terms, and that's going to be them numbers right there. So I'm going to put mine in order. Start with my x squared. Then I'm going to bring down that positive 4x. Then I'm going to figure out what a negative 2 and a negative 4 add up to. So they're like signs. So when they're like signs, add them and keep that sign. So a negative 2 and a negative 4 will give us a negative 6. Okay, so you cannot end up with a single number on this one, number 9, because I didn't give you no numbers to put in for the x, okay? All right, y'all, number 10 is subtraction also, but this time they will give us a number. So they want to let f of x equal x squared minus 4. G of x is going to equal 17 minus x. They want us to find f minus g of 7. So they're giving us a number to put in this time. I'll work it the same way as here, except I'm going to put my numbers in, okay? So f minus g of x will equal our f minus our g. And remember, whoops, this is a 7 here, my bad. So that's f minus g is 7. So when I put the f in, I'm putting a 7 instead of the x. So that'll give me 7 squared minus 4. Same thing with g. When I put it in, I'm putting a 7 in place of that x. So this will be 17 minus 7. Now, y'all, what I do on this one, since they gave me numbers, I'm going to work this parentheses, work this parentheses. My last step will actually be the subtracting, okay? All right, so let's go. 7 squared is 49 minus 4. Over here, I can actually do my 17 minus 7, and that'll give me a 10. All right, finishing out the first parentheses. 49 minus 4 gives us 45. Minus, well, y'all, I can't do nothing to that. All I got in there is a 10. So I'm going to bring that out as a 10. And then finally, I can subtract 45 minus 10 and get my 35. All right, circle number 10. That was the third one I got work on, okay? So far, you got to show work on 5, 7, and 10. All righty, y'all, questions on that page? And I'm hoping it's not that bad this second time around going through this stuff, right? All right, so let me get these
No,
pages
it's
open.
not that bad.
No, and y'all sort of getting a double dose of it now, so. All righty, so that puts us on 11. So 11 was one of those where they wanted us to find the domain of these functions for the sum, the difference, and the product. So this number 11 says for the pair of functions, f and g, determine the domain of the sum, difference, and product of the two functions. Now, let's see the functions. I got f of x will equal 1 over x minus 8. G of x equals 2x to the third. Now remember, when y'all did this problem in MathLab, the sum, the difference, and the product always had the same domain. So if you can get the first one, we know what the other two will be. Now, I'll go through actually all three of them, setting them up, but they will have the same domain. So I'm going to start with the sum. The sum will be f plus g of x. So it'll be my f plus my g. F is 1 over x minus 8 plus g is 2x to the third. So let me ask you all this on this one right here. Are there any restrictions on this domain? Does all real numbers work for this? Or do you see something that might cause me trouble?
Uh,
The
I
fraction.
was gonna say trouble because there's a fraction, but
Okay,
Yeah.
you're right. I got a fraction here, right? So
right.
that means since that x is in that denominator, there might be a number that makes this undefined here. So since you got a fraction, and good job, because that's the main thing, that's the only thing we're looking at this point. So I'm going to set the x minus 8 equal to 0 and see what makes this equal 0. And you know, to solve that, we're just going to add 8 to both sides. So you get x equals 8. That means 8 minus 8 makes that 0. 1 divided by 0 is undefined. So you cannot add that together when x is 0. So on that one, our answer will be x such that x is a real number. And this is where they'll give you the boxes. I was thinking it was that earlier one, but it'll be this one. And then you got to put in x not equal to 8. Okay, so this one you physically got to put this in. All right, good job. The difference, that'll be f minus g of x. Well, you always want to set up the same way, other than the adding is going to be a subtraction. So it'll be 1 over x minus 8 minus 2x to the third. Well, guess what? There's only one thing I'm worried about again, and it's the same fraction. But I already know what the x cannot equal. It cannot equal to 8. So the domain is going to be exactly the same. X such that x is a real number and x cannot equal that 8. So then they said, okay, how about the product? So they'll pop up these one by one as you're going through them. So the product, that's going to be f times g of x. So that'll be my f, 1 over x minus 8 times my g, which is 2x to the third. Same situation, right? I got a fraction times 2x to the third. There's only one number that kills me, and it's that fraction if I put in that 8 again. So notice, they're all setting up the same. That's why they're all going to have the same domain, basically. So for the third time, x cannot equal 8. So y'all, x such that x is a real number and x cannot equal 8. Okay, so you're definitely going to get a fraction on your number 11. They'll have something like x minus 8, x minus 5, x plus 3, but it's going to be the same thing, okay? All righty. Number 12 is the same thing, except this time they want me to find the domain of f divided by g. So for the pair of functions, f and g, determine the domain of f divided by g. Now they're giving me f of x equals 7x minus 5. G of x equals 5x minus 35. All right, so now they're saying f divided by g. So f divided by g will equal my f on top, 7x minus 5, over my g, which is 5x minus 35. Well, we got a fraction for sure. So I'm only worried about the bottom of it, remember. The biggest mistake I get is people work the top. Well, remember, the top can be 0. We're only worried about that bottom. So set 5x minus 35 equal to 0 and solve that for the x. So y'all, we're going to what? Add 35 to get the x's by themselves. So that's going to give me my 5x. That 35 cancels on the left side. 0 plus 35 is 35. And then I guess all I got to do now is what? Divide by 5 on both sides. So there we go. That gives me my 1x, what I wanted. Oh, what's that? 35 divided by 5. That's what, a positive 7.
7.
All right, so on that one, pretty much the same thing we did here, except we're going to put an x not equal to 7 in that box. So it'll be x such that x is a real number and x cannot equal a positive 7. Okay, y'all, so that's the trick on the domains is you're only worried about fractions. And on the fractions, you're only worried about that denominator. All righty, y'all. 13 is a composition where I had the F compose G stuff. So this one says given f of x equals 2x plus 1. G of x is going to equal x to the third. They want me to find f compose g of a -1. This is where we put like the function into a function. Now remember, f compose g of -1 is the same thing as f of g of -1. So what that means is I'm going to find g of -1 first. Once I got that answer, I'm going to plug it into the f equation. So first, g of -1. Well, y'all, g is x to the third. So g of -1 means this will be -1 to the third. All right, so I got a -1 times -1 times -1 gives me a -1. That means this -1 now goes into the f equation. So my second step, I'm going to find f of -1. So remember, I'm putting that -1 into the f. So that'll give me 2 times -1 plus 1. All right, y'all, that's going to give me 2 times -1 is a -2 plus 1. And let's see, -2 plus 1 is a -1. Final answer. Now, mine only worked out like this because I had a 1 on mine. So f of g of -1 equals -1 on this one, okay? Now, if you get other numbers like 2 or 3, it won't be quite the same answer going through, okay? Oh, 13 was the fourth one. Circle it. Fourth one to be work on, okay? So we've had 5, 7, 10, 13. All righty. So y'all watch this one. 14 says use the horizontal line test to determine if the function is 1-to-1. Now this one they're going to give you a graph. So let's see, my graph has an X and a Y. All right, so this graph, the left side is coming up. And then it's doing that on the right side. And then in the middle, it sort of has upside down parabola. So the horizontal line test is going horizontally across it. But it's basically the same as the vertical line test. If a horizontal line intersects that graph more than once, it's not 1-to-1. So let me see what my chat's saying. So chat's saying no, so good job. That is definitely not 1-to-1 because my horizontal line intersected it more than once. Okay. So remember, vertical line test for functions, horizontal line tests for 1-to-1. Either test, if it intersects more than once, you better put no. Okay. All righty. So this number 15 said, hey, determine if 1-to-1. Then it says, if it is, find a formula for the inverse. Oh, and we'll circle number 15 because it was the last one that I'm going to make you show work on. So 15 was the last one that you got to send me, okay? All righty. This function is f of x equals 9 over x plus 4. So if you want to see a graph of that, I'm going to go graph it for you real quick on my calculator. And that way you can tell if it's 1-to-1 or not. So I'm going to go to my calculator, go to y equals. Now, if I want it to look like a fraction, I'm going to hit alpha y equals first to get the fraction nd. On top, we had a 9. On bottom, we had an x plus 4. Now, I just want to look at the graph. So I'm going to hit graph. And y'all look at that. If you run a horizontal line on that, it's not intersecting that graph more than once. So it is definitely 1-to-1, okay? And y'all, I'll tell you a trick. Everybody's number 15 is definitely going to be 1-to-1. So yes, it's 1-to-1. So that means we're going to find a formula for the inverse. So this is where we did all that swapping stuff. The first thing I do is change the f of x into a y. So you get y equals 9 over x plus 4. Then if you remember, I switch the x and y around. We're going to switch the x and y so that this becomes x equals 9 over y plus 4. Now, y'all, it's just a matter now of solving it for the y. I'm going to do it the way I did it when we did it on homework, but there's more than one ways you can solve this for the y, okay? So the way I do it, since I got a fraction here, I'm going to multiply both sides by y plus 4. Because if you notice on the right side, those y plus 4s are going to cancel each other out. So on the left side, you got y plus 4 times x. On the right side at the moment, all that's left is the 9. All right, so check this out. A lot of people like to distribute that x, but I think that's doing more work. What I'm going to do, instead of multiply that x times that y minus plus 4, I'm just going to divide both sides by the x. So I'm going to divide both sides by x. But look what's happening. On the left side, those x's cancel out. So all that's left on the left side is y plus 4. And I don't even need parentheses no more. And on the right side, it's going to equal the 9 over x. So all I did, y'all, from here, when I had x equal that, to this point, all I did, if you noticed, I swapped them, didn't I? The y plus 4 is now where the x was. The x is now where the y plus 4 was. So basically, we just flopping them. But I do got one more move. I got to get this y by itself. So I'm going to have to subtract 4 from both sides. So look what happens. The y comes down. That cancels on the left side. The right side, none of this is like terms. So that's just going to be 9 over x minus 4. So we now have it solved for the y. Now remember, Math Lab is going to give you the f inverse of x notation, the f negative 1 of x. What you got to do is put in the answer here. And the answer you're going to put in is 9 divided by x minus 4. Okay, y'all. So y'all's are really going to be similar to this. Pretty much the only thing they'll probably change is the 9 and the 4. Okay. All right, so I'll let y'all catch up a second, and then we get to do systems of equations. That paper fixed. All righty. So 16. Now I'm going to solve these systems by hand on my review, but you can use your calculator matrix stuff for these. So 16, if you did it on calculator, is a 2 by 3 matrix. 17 will be a 3 by 4. So we're going to solve by elimination. So I got 5x plus 4y equals 44. 4x plus 5y equals 46. So that's my two equations. Well, y'all, let me ask y'all, are any of y'all working these by hand?
Yes.
Maybe. I believe I am.
Okay. So yeah, I'm going to do them by hand then. So I just got to figure out if I want to get rid of the X's or the Y, and y'all, this one, it don't look like it matters. I got a 5 and a 4 and a 5 and a 4. So I'll do the X's on this one. So I'm going to start out by eliminating the X, and then I'll figure out what the Y is. Now, I got to figure out the smallest number I can turn a 5 and a 4 into. Plus, one of them's got to be negative, remember, for them to cancel. So I think 20 is the smallest number we can do with these. So since 20 is the smallest number, I'm going to make this first one a positive 20 by multiplying that whole equation by 4. The second one, I'll make that a negative 20 by multiplying this whole equation by a negative 5. So 4 times 5 gives me 20x on the top equation. 4 times 4 gives me 16y. 4 times 44 gives me 176. All right, now I'm going to do the negative 5 through this equation. Negative 5 times 4 is a negative 20x. Negative 5 times 5 is negative 25y. Negative 5 times 46 is a negative 230. But y'all notice, now I can cancel these x's out. So let's add negative 25 and 16 is what, a negative 9y. This side's going to give me, let's see, negative 230 plus 176. Oh, what's that? It's negative 54. All right, so now we're down to one variable, one little equation. We can now solve that by dividing by that negative 9. So negative 9y divided by negative 9 equals negative 54 divided by that negative 9. So that cancels, giving me a 1y. Negative divided by negative will now make this a positive 6. All righty, so I know what the y equals. So this is where I went in and I back substituted into one of these two original equations. So I'm going to back substitute. Since I know y is 6, I'm just going to use the first equation, 5x plus 4y equals 44. And I'll put my 6 in for that y. So 5x plus 4 times 6 will equal 44. All right, so you want to multiply first. So bring down to 5x. 4 times 6 is 24. That's going to equal 44. And y'all, at this point, we'll subtract 24, then divide by that 5. So I'm going to subtract my 24. I now get my 5x. Those cancel. That's giving me what, a positive 20. All right, y'all, final step, divide by the 5. So that cancels, giving me a 1x. 20 divided by 5 is 4. Now, here's the big thing on this problem. When this problem is put in MATLAB, it's got to be the form of an ordered pair. So it must be in form of ordered pairs. Okay? So the x goes first, then the y. So you're going to have a 4 for the x, a 6 for the y, and then close your parentheses. Gotta use parentheses on that one, y'all, or it will mark y'all wrong. All right, so remember, on the calculator, you would edit it, do 2 rows by 3 columns, punch in your numbers, and then on the calculator, you're going to do the RREF to it, okay? All right, y'all. So you know what's coming next, right? Will be a 3 by 4. So 17 says solve. All right, so my first equation is 7x minus y plus z equals 4. Then I got a 2x plus 2y minus 3z equals 6. And then I got x minus 3y plus 2z equals a negative 10. Now, on the calculator, that is a 3 by 4, okay? I'm going to do this by hand. So I always start out by making this like equation 1, equation 2, and equation 3. That way it's sort of easy for y'all to keep up with what I'm going to do. Because remember, my first step is to turn this 3 by 4 into a 2 by 3 system, okay? So y'all, I'm picking a variable to eliminate, and I think I'm actually going to eliminate the z here. So I'm going to eliminate z first. So what I'm going to do to eliminate z, the first one I'm going to do, I'm going to multiply this first row by 3. That way I got a 3z here, and I'm going to add it to this row with that negative 3z. That'll cancel the z's on those. So I'm going to multiply my row 1 by 3 and add to my equation 2. So I'm changing 1 and then going to add the 2. So let's multiply row 1 by 3. That'll give me 3 times 7 is 21x. Minus 3 times y is 3y. Plus 3 times z is 3z equals 3 times 4, which is 12. Now, I didn't have to change the second row, so I'm going to bring it down. 2x plus 2y minus 3z equals 6. Now, what I'll do when I add these two together, I'll call that new equation 4. All right, y'all, so let's see. 21 and 2 give you 23x. Negative 3 and 2 give you negative 1y. The z's cancel. And then 12 and 6 give me 18. So that's the first equation of the new 2 by 3. Now I got to get the second equation. But remember, since I used row 1 and 2, I now got to use the third row with either one of these two. So that third row has a positive 2. So what I'm going to do is change row 1 and make that into a negative 2z. So I'm going to multiply row 1 by negative 2. So multiply row 1 by negative 2. And then we're going to add to equation 3. So remember, I used 1 and 2 here. I had to use equation 3 on the next system. Now, on mine, I used row 1 twice. I changed it here, and then I'm changing it here. So let's multiply row 1 by negative 2. I'm going to get a negative 14x. Negative 2 times negative 1 makes that a positive 2y. Negative 2 times z makes that a negative 2z. And then negative 2 times 4 is a negative 8. Now, I didn't have to change row 3, so that was just a x minus 3y plus 2z equal negative 10. Y'all, when I add them together, that'll be my row 5. So let's see, negative 14 and 1 gave me negative 13x. 2 minus 3 gave me a negative y. These z's canceled. And then a negative 8 and negative 10 gave me negative 18. Was there a question, y'all? All righty. So you now have two equations. They both got x's and they both got y's in them. So that's why you had to eliminate the same variable twice, okay? So these two I can now put together. 23x minus y equals 18. Negative 13x minus y equal to negative 18. So now it's like you're starting with a 2 equation by 3. So y'all, I got to pick a new variable to eliminate. And y'all, I think I'm actually going to eliminate the y on this one. I don't even know what the smallest number that a 23 and a 13 go into. Ooh, that'd be big, I bet, won't it? All right, don't even want to think about that because I can change this one real easy. I got two negative y's. If I multiply this one by a negative 1, that'll make this all positive. Now, you could have multiplied the top one by negative 1 and made that y positive. Either way. So what I'm going to do, I'm going to multiply the second equation by a negative 1 and then add to my first equation. Okay. But remember, like I said, either one you could have changed. So I'm not changing the first one, so I'm going to bring that down. 23x minus y equaled 18. Now, all that negative 1 is doing is changing that to a positive, that to a positive, and that to a positive. So I now have 13x plus y equals 18. So y'all, let's add these together and see what we got. 23 and 13 is what? 36 x's. The y's cancel. And then 18 plus 18 is 36. We are now down to one equation with one variable. So we're going to divide both sides by 36 and get that x. Well, y'all, it looks like all these 36s divided by 36s is just going to give me a 1x over here. And then 36 divided by 36 is 1. So I finally know what the x is. So now I get to back substitute. So since I know the x is 1, I can use one of these two equations, solve it for the y. Once I know what the y is, I'll go up into one of the original 3 equations and get the z, okay? So remember, from here, I'm going to the back substitute. So I'm going to use the first equation, 23 times x, which is 1, minus a y has to equal 18. Okay, so that's going to be 23 minus y equals 18. I'm going to subtract 23 from both sides now. Starting to solve that. And look, that cancels. All that's left is a negative y. That's going to give me what, a negative 5? But remember, y has to be positive. So since I got a negative in front, I got to divide both sides by negative 1. So look, that cancels, making that a positive y. Negative 5 divided by negative 1 makes that a positive 5. So we now know that x is 1 and y is 5. So what I'm going to do, I'm going to go into my original equation, put a 1 there, a 5 there, and solve it for the z, okay? So y'all doing that. We're back substituting for the second time. So that'll be 7 times 1 minus y, which is 5, plus a z has to equal 4. All right, so 7 times 1, that gives me 7 minus 5 plus z equals 4. Look here, you got like terms on this side. So let's see, 7 minus 5, that'll make that a 2 plus z equals 4. So this one, I don't have to do no dividing or nothing. All I got to do is move that 2 over by subtracting 2 from both sides. And y'all look at that. That cancels. I get my z. 4 minus 2 gives
2.
me a 2. Now, the last one you had to use parentheses for. This one, MATLAB gives you the parentheses. And it gives you 3 boxes. So you don't have to put parentheses. You just got to put the numbers in the boxes in order. So this will be an X, Y, and Z. So that'll be a 1, 5, and positive 2. Okay, so remember, 16, you had to put parentheses because they didn't give them to you. 17, they give you the parentheses, okay? So just use the boxes to put in your numbers. All right, y'all, so I'm going to let y'all catch up real quick. All right, so 3 more now. The last 3 dealt with the section 3.7 where we were graphing lines and sort of shading. All right, so this will be 18. So 18 says graph the inequality. They're giving me 3x minus 2y less than or equal to a negative 4. All right, so remember, you can do these on the calculator. I'm doing them all by hand. But either way, you really want to solve this for the y. So just like a while ago, I'm going to solve for y. So y'all to do that, you're moving the 3x over. Then you're going to divide by that negative 2, okay? So start out by moving the 3x by subtracting. So notice those cancel. You get negative 2y less than or equal. Once again, you don't have like terms, so I always put my x's first, negative 3x, and then minus my 4. Now, the most critical point on this problem is I'm going to divide by negative 2. Since I'm dividing by negative 2, I got to take that inequality and reverse it. So this inequality will now change into a greater than or equal. Okay, so that's the biggest thing, remember. Reverse the inequality. Since dividing by a negative number. All right, so -2 divided by -2 makes that a 1y like I needed. It's now greater than or equal. And y'all, negative divided by negative makes that a positive 3/2 x. And then that -4 divided by -2 basically makes that a positive 2. So this is the equation that you want to graph based on, okay? So remember, I'm doing this by hand, but at this point, you could put this in y1 on the calculator, make it shade and do all that fun stuff. You can find your points on the table to plot if you want to. All right, so I'm going to use two numbers. I'm going to use 0 for sure. And since I got a fraction here, I'm going to use 2 for my second one. So if you put a 0 in here, so let me see what's happening on my chat. So Vidi, yes, only on a dividing by negative. If this would have been a positive 2y and we divided by positive 2, we would have left that the same, okay? We wouldn't have reversed it dividing by positive numbers. All right, I'm putting a 0 in here. 0 times 3/2 is 0. 0 plus 2 gives me a 2. And then I'm going to put a 2 in for the x. Well, if I put a 2 in for the x, it cancels with the fraction. So they're going to cancel out, and all that's left is 3 plus 2, which is a 5. So y'all got my 2 points. So now this is going to be a straight line. So in Math Lab, first thing you want to do is you're going to use the line tool. Now, y'all, the first thing we got to figure out for Math Lab is whether I want this to be a solid line or a dashed line. Because remember, by default, MATLAB will have this right here. By default, the solid line will be highlighted. But remember, if you got a dash line, you got to highlight it. Well, I'm looking at that. I got a greater than or equal. Since I got an equal, I would use the solid line. But remember, by default, it's on solid, so you don't have to switch it at this point. So I'll choose my line tool. I'm on the solid line. Now I'm going to plot 0, 2. Well, there's 0 on the x's, up 2 on the y. And then 2, 5 will be right 2, up 5. All right, so at that point, when you draw that second point, MATLAB's going to come in and draw your line for you. But now remember, we got to shade this. So you're looking at the final equation. It's greater than shades above the line. So there's a little paint can. You're going to grab that paint can and drag it above the line here. And when you drag that little paint can on the top of the line, it's going to come in and shade everything above that line. Okay. Now remember, on calculator, when you put your y equals 3/2 x plus 4, if you want it to shade, you're going to arrow all the way left and the shade on top, you got to choose in the calculator, you're going to choose the triangle that's bigger on top, okay? All right, y'all, this one says graph the linear inequality. And this one is x less than 4. So if you got an x equation and there's no y variable at all, it's just the x, this equation, when you're done, is going to be a vertical line. Okay? Also, I know what every single one of these x values has to be. Since this is x is less than 4, we treat it as if it was x equals 4, which means no matter what, each of these x values has to be a 4 on this one, okay? Now, if you have a y less than 4, then every one of the y values would be 4, okay? Now, since every x has to be 4, it don't really matter what y values y'all pick. So I'm just going to use easy numbers, 0 and 1. All righty, so we're going to have 2 points. Unfortunately, this one you can't do in MATLAB because it's an x variable, okay? So let me go out about 5. All right, so basically what this means is we're going to have a vertical line, and it's going to be at the x value of 4 on our graph. So 4, 0, 1, 2, 3, 4. There's my 4, 0. 4, 1, 1, 2, 3, 4, up 1. But y'all could have used 4, 2, 4, 3, 4, 4. You could have did 4, -1, 4, -2. It don't matter. What matters is that it's at the 4. Now be careful on this one. You're going to choose the line tool. But notice this one don't have an equals on it. So you physically got to change this and highlight the dashed line when you plot it, okay? So that MATLAB, when you plot these points, it's going to make a dashed line for you. So then less than. Since this thing is pointing left, less than is to the left. So you would grab that little paint can, drag it to the left side of your line. And when you do that, MATLAB is going to come in and shade everything left of your line. Okay, so x less than 4. That x value is less than 4. That x value is less than 4. All these x values over here are definitely less than 4. Okay, y'all, so just be careful. What I get people on this one usually is the line. They forget to go to the dashed line on that. And if you don't put a dashed line, MATLAB will mark that wrong, okay? All righty, y'all. So finally, number 20 was where we had to do the system, where we graphed both of them and we looked for where they were overlapping. So let me let y'all catch up on that. All right, y'all. So like I said, number 20 is a system. But I guess the good thing about number 20 is you didn't have to solve it for the y. They were both already solved. So they just want me to graph the system of inequalities. Now, both of these will be straight lines when you graph them. So the first one is y greater than or equal to x plus 6. The second one is y less than or equal to 5 minus x. So I got two equations already solved. So I'm just going to make up an x and a y for both of them. Now, the thing about this one, y'all, you don't have to physically graph it. It'll have 4 pictures, and you're looking for the picture that represents your double shaded area, okay? So, y'all, I'll use the first table for the first line, the second table for my second line here. All right, let me get me a graph ready. Ooh, I might go out about, I'll try 5 just to see what we get. All right, so let's see what happens. I'm going to use 0 and 1 for all my x's on both of these. So the first equation, I put a 0 in for the x. 0 plus 6 will give me 6. If I put a 1 in for the x, 1 plus 6 will give me 7. All right, so I'm going to plot that one first. So it looks like I need to make at least another mark or two here. All right, so 0, 6 will be 0 up 6. Then I had 1, 7, which will be right 1 and up 7. Now, since you got equals, this line will be solid. Now, this first line is greater than. So y'all, my first line will shade above the line. So it's going to shade all this above that line. Now we do the second line. So the second one, if I put a 0 in for the x, 5 minus 0 is 5. If I put a 1 in for the x, 5 minus 1 is 4. So now let's plot these points. 0, 5 will be 0 up 5. 1, 4 will be right 1 up 4. All right, so that's going to be a solid line also. Now that line was less than, so it's going to shade below that line I just made. So it's going to shade all of this below. So for this problem, the answer will be the one where it's shaded right here to the left. So your final answer, see if I can draw that, will sort of look like a shaded rectangular area to the left side representing this double shaded area, okay? So it'll give you a shaded area like this, a shaded area up top, a shaded area to the right, and a shaded area to the bottom. The only one that works is the one where it's double shaded to the left, okay? All right, y'all, so guess what? That is test 1. So the biggest thing for this test is the test 1 review. Counts as a quiz. So test 1 review counts as a quiz, and you can do multiple attempts, and it will keep the highest score, okay? So get good on that review. Test 1, has one attempt only. Okay, so you want to get good on that quiz before you do your test. And remember, this thing is due February 25th, which is Sunday, by midnight. Okay. Now, we will start new material on Thursday. It's not too bad. We keep it sort of mellow, but we will have new material on Thursday to keep us going. Okay. So you can do your test by Thursday, or you can actually wait till the weekend and do it. But y'all, that final test is due by February 25th. Test will not let you work past the due date. So test will not let you work past the due date. Okay. So if you're not done by midnight on the 25th, it'll put a 0 there. And then you'll have to use that 0 for your replacement test at the end of the year. Okay. But y'all start out with a good grade. Do that quiz, please. Get you a good grade on it. Then knock out that test. Okay. Oh, yeah, I see my chat lighting up. Let me see what it's saying. Okay, so the ones that I needed the working for, let me write them down here real quick. So y'all, the ones that need numbers, you're going to show work on 5, 7, 10, 13, and 15. So if you email it, you'll email it to my email, erathpon@uaptc.edu. If you text it to me on the phone, 501-472-6782. Either way, whatever's easy, okay? Just make sure when you're taking your pictures that I got your name on there. Especially if you texting it to me. Email, I'll know who it's from because it'll say who it's from on the email. But if you do text it, put your name on it. All righty, y'all. So let's see. Questions over this.
No questions for me.
All righty,
No.
so all right, I'm gonna stop the recording so I can send that out in a little bit.